Welcome, students, to today's lecture, which is going to be on basic stoichiometry. So far what we've been doing is we've been looking at some basic things to do with stoichiometry, and we're kind of getting the feel for some of the things that we're going to need to do for it. And most of that is, getting you guys used to working with molar masses and balancing equations. For today, what we're going to do is we're going to do kind of like a relatability lecture for this, where we're going to take the concept of basic stoichiometry and we're going to apply it to something that I know is very important for you guys as teenagers, in your time of life right now, which is food, okay? I know that right now the easiest way to teach teenagers about stoichiometry is to relate it to food, because essentially what stoichiometry is it is cooking, but with chemistry. So without much further ado, we're going to go ahead and begin our lesson here. And we're first going to go ahead and define stoichiometry, okay? And stoichiometry is a way for us to go ahead and measure out the correct amount of reactants to get a set amount of products, okay? And this is kind of just like a ratio-like definition that we're using here, because we're trying to see essentially like, if we have this much starting material, how much stuff can we make? Or if we have this much material made, what was our efficiency? Or we could be doing a whole bunch of things, but realistically what we're trying to do is to take a look at our ratios and be like, okay, how much can I make from this based off of a very specific recipe? And you guys are already familiar a little bit with some of these concepts, because that's what we've been doing with balancing equation, is finding our right ratios for how things combine. Today, we're just going to go ahead and add the actual measurements to it. So we're actually going to measure different compounds together and, make our actual recipes here, okay? And the simplified version, if you put X reactants into a reaction, how much products can you get out of that reaction? Okay. As I said before, this is going to sound a little bit complicated now, but once we put it in together with food, it should help to, coalesce into your brain structure a little bit more. Okay. Now, if you do have s'mores, I would recommend, or you have the stuff to make s'mores, or to get a marshmallow. If you have a way of getting a marshmallow right now, I would recommend that you go ahead and get it. And if you eat a marshmallow throughout this unit, it will help you to understand it. And I know it won't make sense why, but just trust me on this. You want to have a marshmallow. Okay? So, what I have here is I have made for us the balanced equation for how to make a s'more, okay? And a correct s'more is going to have 2 graham crackers, okay? So here we have 2 graham crackers, one on the top and one on the bottom. We have 3 pieces of chocolate, okay? And we're talking like the Hershey's chocolate, because that's the good stuff, okay? Don't get any of that knockoff stuff. Like, you need the Hershey's. And then 1 jumbo-sized marshmallow, okay? And you need to make sure that marshmallow is nice and toasty if you're making s'mores, okay? You put all of those together, and together, then you'll have 1 s'more, okay? So, 2 graham crackers, 3 pieces of chocolate, and 1 marshmallow makes 1 s'more, okay? So, how many s'mores can we make from 20 chocolate bars, okay? Now we have a different problem, okay? And what I've done now to try and help us out a little bit is I have given us our conversion factors, okay? And our conversion factors are how you can buy these different things at the store, all right? So when you go to a store, you cannot buy 2 graham crackers. Okay? There is no store that will allow you to buy just 2 graham crackers. And if that store exists, it's probably weird and sketchy, and you should probably not be buying your graham crackers loose like that. When you go and you buy some chocolate, you don't buy 3 individual pieces of chocolate. No, you can buy a bar of chocolate. And when you buy marshmallows, you can't buy a single marshmallow. You have to buy a bag, and that'll have like 40 marshmallows in it. Okay? So, we use conversion factors all the time in cooking, but we don't really think about them as conversion factors in cooking. Okay? Now, this right here, as a reminder and pullback, is moles. So we're actually using this as a placeholder for moles. Okay? And remember, if we're going to go ahead and read this as if it's a stoichiometric process, we would say that 2 moles of graham crackers and 3 moles of chocolate come together to wait with 1 mole of marshmallows to make 1 mole of s'mores. Okay? So this is a nice shortcut. Okay? Now, I told you before that our goal is always to get to moles. And the reason why is right here, okay? We're going to use these conversion factors to get us to our moles of everything proper, okay? So let's go ahead and solve this first question, though. How many s'mores can we make from 20 chocolate bars, okay? So we're going to go ahead and start, and we're going to write down what we have. So just like we've been doing this entire time, we're going to write down what we have. And we have 20 bars of chocolate. Okay? Now, we don't want to have 20 bars of chocolate. We need to figure out how many pieces of chocolate. Okay? Pieces of chocolate is like our moles of chocolate. We need to get the pieces first. Okay? Well, we see that... Oh, wow. I messed up this calculation here. Hey, let's try that again. Alright. So, we have pieces of chocolate, and we have bars of chocolate. 1 goes with bar, and 12 goes with pieces of chocolate. Okay? So that'll tell us how many pieces of chocolate we have. Now wait. We're not looking for pieces of chocolate. We're looking for s'mores. Okay? So once we're in the correct unit from our equation here, okay, or once we get to moles, then we can go ahead and compare chocolate to s'mores. Okay? So notice we've made a new conversion here. We're now going to get rid of bars and chocolate, and it's going to tell us how many s'mores we're going to get. Okay? Now, this pieces will end up, going away, a little bit. Because this should be in moles, but we have a little issue. But we're going to be able to figure this out now. So we're going to go ahead and multiply the top. So we're going to have 20. And then we have to put in our numbers. 1 goes in here from s'mores. And 3 goes in here for chocolate. So we're going to do our math. So we'll take 20 times 12 times 1 divided by 1 divided by 3. And it looks like if we have 20 chocolate bars, we can make a total of 80 s'mores. Okay? So 20 chocolate bars will give us 80 s'mores. If you were following along with that, congratulations, you've just done stoichiometry. And that's all that stoichiometry really is. It's just using conversion factors like we've been using in this section to go ahead and figure out different ratios and seeing the maximum amount of product that we could possibly make. Okay? Now we're going to go ahead and go into the next example. And this next example is actually one of my very favorite foods here. And it's macaroni and cheese. Alright. So, Mr. Bradley is a big mac and cheese fan. I ate it all the time as a kid, mainly because my mother's cooking was a little suspect. But, don't tell her that. And I don't think that she'll ever watch my YouTube channel, so we might be safe. If not, I might get a call later on. But my mac and cheese recipe is actually a really, really simple one, okay? I use 8 ounces of noodles and 8 ounces of condensed milk and 6 ounces of cheese to make 4 servings of mac and cheese. Alright? Now, don't worry. I know that a whole bunch of you were like, oh man, Mr. Bradley, you forgot to salt your food and there's no flavor. Don't worry, I add extra things here too. This is just the base. You can add other things to this. I personally like to add fire roasted hatch green chilies. That's something from my my Colorado influence. The hatch green chilies have a nice sour pepper flavor, and they can come with all sorts of heats. I am a big fan of super sources of cheese. Now, I know that I end up weighing this out exactly. So I actually have a balance at home that I use to weigh out to get the right amount of mac and cheese. Okay. I use a scale. I understand. I'm a nerd. Okay. But we're going to go through this process here. And our first question that we're going to ask is, how many people can you serve if you have 235 packets of cheese? Alright. And then we have secondary questions. How many boxes of noodles will you need to feed them? And how many cans of condensed milk will you need? Okay. Well, first we have to get our conversion factors. And in this case, we have 1 pack of cheese equals 8 ounces. 1 can of condensed milk is 10 ounces. And 1 box of noodles is 16 ounces. Okay? So, all of those things, you can actually go and look at the things on the grocery store, and you'll find that, all of those should end up being true. Alright? So, when you go to the grocery store, you can't just pick out 6 ounces of cheese. Okay? You have to weigh out a different amount. So, let's go ahead and start the first question. How many people can we feed? So what we'll start with is we're going to go ahead and write down what we have. And we have 235 packets of cheese. Okay? Each cheese, 1 pack of cheese is going to equal 8 ounces. Okay? Then we're going to say, okay, 6 ounces of cheese, because we're going to go from cheese to mac and cheese, gives us 4 servings of macaroni and cheese. So we'll go ahead and pull out our calculators now, and then we'll take 235 times 8 times 4 divided by 1 divided by 6. Okay? And it says that we'll be able to feed 1,253 people. Okay? So the answer for this first one is 1,253 people. And it says 0.33, but we're not feeding 0.3 of a person. Okay. Now, we had 2 other questions that we had to answer there. Okay. One is how many cans of condensed milk and how many boxes of noodles. Alright. Now, you could theoretically re-input your numbers and say, oh, well, I need 1,253. Or you can do the lazy way, and here, instead of converting to servings of mac and cheese, we could just convert to noodles. Or we could convert to condensed milk. We don't have to do all of this part again. We could do it the lazy way. Okay? So let's just replace that part. Okay? Instead of that, let's get rid of the old stuff and let's put in the new stuff. Okay? So we're still getting rid of 6 ounces of cheese, but now we're looking for 8 ounces of noodles. And it should be just noodles and not noodles milk, but we're going to pretend that I don't have that error. Times 8, 235 times 8 times 8 times divided by 1 and then divided by 6. Wait. Okay. Oh, wait, I forgot one other part here. Okay. So, we have our ounces of noodles here. Man, I messed up the timer thing. Okay. Wrong run. So we have our ounces of noodles here. Now we need to go ahead and be like, okay, this is how many ounces of noodles we need. We need to go ahead and figure out how many boxes of noodles. Okay? So we're going to have a second conversion here. Okay. And we're going to go ahead and get rid of ounces of noodles. And up on top, we're going to put boxes of noodles. Okay? Now, box, we see that we need 1 box equals 16 ounces. All right. So now we have our complete stoichiometric process. We now know how many boxes of noodles we need to to feed 1,253 people. Okay. So we'll take 235 times 8 times 8 times 1 divided by 1 divided by 6 divided by 16. Okay, and it looks like we're going to need 156 boxes. Okay, now let's go ahead and do this same process, but we're going to figure out cans of condensed milk. Okay, now this again is condensed milk. All right. So we see that it's 8 ounces of condensed milk. We could put this in directly from our equation here. And now we have to convert from ounces of condensed milk to cans of condensed milk. So we're going to put cans here. We'll put ounces here. And we need 10 ounces for 1 can. So to go ahead and figure out this one, we're now just going to multiply through. 235 times 8 times 8 times 1 divided by 1 divided by 6 divided by 10. And it looks like we're going to need 251 cans. And this should technically be 157 because we needed 1 extra because it was 0.66. Okay? And that's how we go ahead and solve for these types of problems here. Alright? So we just go ahead and convert first into the unit that's in the equation. And often the equation is going to be in moles for us. Okay? So that's why I got you guys used to figuring out problems that ended up being in moles. Once you convert it into moles, then you can go ahead and convert it to whatever unit you need to. And then sometimes you'll have to go ahead and convert it to whatever useful weighing unit or purchasing unit you need to be able to. So often what you'll see in chemistry is that we're going to either measure things out as a volume of liquid, or we're going to measure it out in terms of grams. So you're going to have to be able to do both of those conversions, usually at the beginning or end of a stoichiometric problem like these right here. Okay. Now, there are going to be some other terms that we are going to come across. Okay. And the first term that I want to make sure that you guys write down is going to be excess reactant. And this is often going to be the reactant that you'll have extra of at the end of a reaction. It's usually what you have unlimited amount or that you make sure doesn't get all the way used up. Okay. The second one is the limiting reactant, and this is going to be the reactant that's going to get used up first, okay? And this kind of limits you with how much product that you can end up making. Alright, so when we did our mac and cheese one, what we ended up doing was we said that cheese was going to be our limiting reagent because cheese is kind of expensive, okay? And then the last one is going to be percent error. And percent error is going to be one, we'll have an entire lesson on calculating it. But this is, saying like, here's how much we actually made versus how much we expect it to make. And it's a measurement that, especially when we do more and more labs, that we're always going to be using it. So I want you guys to see it now. If you end up like making your 4 portions and then you drop one and then the dog eats it, like that means that you're going to have an error in your measurement of about 25% because you lost about a quarter of your product. So I just want you to be aware of those terms right there. For right now, we're going to go ahead and end this lesson, and you should be able to answer all of the questions that are in your worksheet for today. I hope this helps explains it, and I hope that I didn't make anybody too hungry with talking about, mac and cheese and the other s'mores. Though, the mac and cheese is a pretty good recipe. Alright, for now, I'll go ahead and leave you guys off, and remember, stay lazy.